cameras. Not the rank isn't important, it is, but many of the higher ranking events, for example.
I can't hear you, so I guess you said yes. If there's any audio problems, I hope you let me know. Otherwise, I'll just begin. First of all, it's actually late in the evening here, and I'm going to show you some live video from my telescope, which is currently posted somewhere in the sky. But let me begin. My first presentation, can I do something to make it not that loud? Is this better? Hello? 1, 2, 3, 4. Is this better? Okay, I'll just continue. My first presentation is about a new software for recording video, which I was developing for a while. And the way the idea came to me was after I was recording some very long videos of faint stars, were running with integration of say 64 or 128 frames per second to get down to magnitude whatever 15 or 16 to actually observe an occultation. I only had very few data points because the same frame was repeated multiple times, when what I really wanted to have is shorter video, because really each of the integrating fields was only representing one valid exposure of the camera. Steve, can you move to the next slide, please? Or is there a way I can do that? Yes. So the way integrating cameras work, as everybody who has used them knows, is that they integrate or they expose for a certain period of time, which is always an integer number of frames, a whole number of frames, and then during the next integration they output what they had recorded the previous integration. And the reason for them to work this way is because they are video cameras and they have to conform to the PAL or NTSC frame rate. And this means they have to output at a constant frame rate. So in this case, I am showing a disappearance of a star. You can imagine this looks like a disappearance, where I have been integrating with 4 frames. And in my first 4 frames, I pretty much see the same image. And then the next 4 frames is the star has started to disappear. And the last 4 frames, the star has disappeared. Can you move to the next frame, slide, please? When we measure this video, and this is something which all of you that have integrating cameras have seen, is that each of the frames is actually repeated multiple times. And if the signal to noise ratio of the video is not very good, this usually will mean that even the individual measurements will probably have different height. So this makes the light curve looks unnatural in a sense, and it could represent problems when we try to interpret what actually happened. Something else which could have been a much better way to record our video would be the next slide, please. If our video camera was outputting only 1 frame per actual exposure, and in this case what we would have measured is a light curve which looks like this. In fact, if we're using a CCD camera, this is exactly what we would be getting. So this is when I thought maybe after all, if I am able to create a recording software, I could output only 1 video frame rather than 4 or 6 or the full integration period. And by doing this, I could dramatically reduce the size of the video files, especially when we're recording at a very high integration. The next slide, please. This is when I realized that there's actually one problem, and this is because for analog video the way we get our timestamps is by the on-screen display timestamps of each of the fields. So what I was thinking of doing is actually averaging all of the fields during the integration period. But if I did that, what would happen is unreadable timestamps which overlap, because each of the frames in the integrating period will have slightly different timestamps. So when they average over each other, you wouldn't be able to read them. The next slide. So this is when I realized that if I am to do something like what I wanted to do, I had to also manipulate the timestamp. And what I decided to do in my ideal scenario is, if I'm able to recognize an integrating period, then I would really want to copy as my start timestamp the first timestamp of the first field, and as my last or second timestamp my last timestamp of the last field. But all the other pixels I would really want it to be averaged between all the fields, because this would improve in some way this signal to noise ratio, because any added noise in the video signal when it as it travels from the camera to the computer will be actually cleared out a little bit. The next slide. So this also meant, however, that the software wouldn't know exactly where the timestamp is located. So one thing it had to do is it needed an input from the user to know exactly where the timestamp is. Otherwise, it wouldn't know how to keep the first timestamp of the first field and the last timestamp of the last field of the integrating period. The next slide. So this is what I actually end up doing. I had a special part, and I'm going to hopefully show you a demo just in a few minutes. And I had to leave it to the user to configure exactly which rows or lines of the video the timestamp occupies. The next slide. Another thing which I realized after that is that if we watch the video in a normal frame by frame way, then the video player or the software which measures the video will again overlap the odd and the even fields, because this is how analog interlaced video works. So I had to also do some little bit of extra work to split the two timestamps, and I decided to show them something like this. So in this case, you can see that my starting timestamp was at 28 seconds 0.97, and then the end timestamp was around 0.6 seconds later. Next slide. So what I decided to do is to try to create a software which is able to do all this, and my goals were to reduce the file size of integrated videos by recording only one frame per integrating period. And also I wanted to be able to do some other things, such as scheduling a recording, or just make it a little bit better, because I wasn't very happy with the alternative of virtual DAB. The next slide. So now I will try to actually show you this software, which is currently running on my observatory computer. So if someone can give me, yes, thank you, and then I still don't have access to share my desktop. I don't see the tabs which I usually see to share my desktop. So I assume I haven't been given the permissions to do this. Okay, that's better. Okay. Can everyone see my desktop? If nobody complains, I assume you can. So when you start the new software, there's a number of things, and I'll first go to my settings. And it records video, so you need to configure the output location of your video. Another thing is, because it can schedule a recording, okay, there's a big time lag, so go slow. When you want to schedule a recording, the software doesn't know the time with the same precision as your GPS. So you need to configure an NTP server, so it will synchronize your computer clock, and it will know the time with a much better precision. So the computer clock time derived from an NTP server will be the actual time which will be used to start and stop your recording. Then the next tab is configuration of the new video file format which I created. So the other problem with the standard video is that it again runs with a fixed frame rate of 25 or 30 frames per second. So I couldn't use a normal AVI file to store the video, so I had to create a new one. And there's some configuration options here which I'll go through later. So when you click the connect or go video connect, the software is able to detect all of the video capture devices which are installed on the machine. And in this case, I'm going to pick this one because I know my camera is connected to this. There's two file formats. You can even record in an AVI file, choosing a different options of a codec. So it supports the HAFYAF lossless, the Logarit lossless. It supports XBit MPEG-4, which is a very heavy compression codec, or it can go uncompressed. But the more interesting option is the AAV, which stands for Astro Analog Video. And then you can choose what to do with, if you have an IOTA VTI, my software can actually read the timestamp on the fly for some configurations. And then I can choose this and I can go OK. And I know that my video is not going to be, you're not going to see you're not going to see my screen with the speed it runs, but basically just trying to adjust the screen, okay, something like this. So basically what we have is a couple of controls which can lock a frame rate. So OccuRec, or that's the way I call the software, can recognize the integrating period on the fly. And at this stage, in this instance, it told me that it's recognized 16 frames. And then if I press lock, it will actually lock it to this integrating period. and it will start outputting only one frame from full integrating period, and it will actually correctly use the start and the end timestamp. And then, of course, you can start a recording of a file, and then you can schedule a recording as well. If you go add, you can choose at what time in UT you want your recording to start and what will be the duration. And I have already successfully used this to record in unattended mode 2 or 3 occultations, which I'm very happy about. So this was my demo. I would like to go back to the presentation. So let me try this. Can you please move to the next slide? I don't know whether I'll be able to answer questions right now because I can't hear, but if you have any questions, you can, I guess, type them or do something so I can hear them. Does anyone have any questions? So the software is called OccuRec, and it's currently in a beta, in a beta stage, and I'll probably send a message to the IOTA groups and the other one for people which would like to use it. Terry, is this a question? I assume there's no question. So I will move on, and then you have a chance to answer the questions to ask questions at the end. So all capture cards which support the direct show will work with OccuRec. So this pretty much means every capture card which will work with virtual DAB will work with OccuRec.